So our next lesson is going to be optimizing quadratics. That means basically finding the min or max. So what you should know is that it always occurs at the vertex, and the vertex is this kind of point at the bottom, or at the top if it's upside down. So we need to know a few formulas to find the vertex. If the equation is in the form ax squared plus bx plus c, then we know the vertex occurs at negative b over 2a. We also know that the vertex occurs right in the middle of the two solutions of a quadratic equation. Finally, we also know if 2 points have the same y-coordinate, then the middle of the two x-coordinates is going to be the x-coordinate of the vertex. So let's look at the first problem here. So we might get enticed by the thing ax squared plus bx plus c in this question and try using this formula, but in fact there's a simpler way. So the question basically asks, if you have a quadratic function and we have these 3 points on it, what's the x-coordinate of the vertex? Well, I see a 7 and a 7 here. Both of these are 7, so the x-coordinate of the vertex is going to be right in the middle of these two x-coordinates. So the middle of -1 and 5, that's just 2, and that's our x-coordinate. Now let's think about the next problem. Well, it's not really a quadratic. It's actually technically isn't. Well, but we can try making it look like one. I know this is 12 minus x and 12 plus x, and I think I can pair them. That's like difference of squares. No biggie. And we can do a similar thing for the tens. So we have our new kind of function is 144 minus x squared times 100 minus x squared. And if you notice, this is basically a quadratic equation in terms of x squared. So that doesn't really matter, because if we call x squared some other variable like z, then we find out that it's just a quadratic equation. We can use the vertex stuff. So according to our second property over here, it's right in the middle of the two solutions of a quadratic equation. The two solutions are x squared is 144 and x squared is 100. So the minimum is going to occur when x squared equals 122. We're going to put that in. And we get 22 times negative 22, which is negative 484, and that is our minimum value. Now let's look at the last question. Well, what we can kind of see is that we have a quadratic equation kind of plugged into a quadratic equation. We have this x squared plus 5x plus 9 kind of both appearing randomly, and it's that thing squared minus 6 times that same thing plus 14. So right now we can do something called substitution. We can pretend that x squared plus 5x plus 9 together is just one variable. We're going to call that z. So we're going to say f of x equals z squared minus 6z plus 14. And first we need to figure out where this minimum value occurs for z, and then we can figure out where this value occurs in x. So the minimum value of z squared minus 6z plus 14, that occurs at the vertex of that function. That occurs when z is negative b over 2a. b over here is negative 6, a is 1. When you put that in, we get z is 3 at the vertex. So we need this function x squared plus 5x plus 9 equal 3. That's just x squared plus 5x plus 6 equals 0. Now, to solve this equation, you can use any method you want. Factoring is probably the easiest. You could do quadratic formula if you're lazy, and God forbid you choose completing the square. But in the end, you get x times x plus 2 times x plus 3 equals 0. And from this, you get x equals negative 2 or negative 3.